With me here on the board is still on laws of indices. We have some examples that involve a combination of your deep knowledge of indices and your knowledge of the several laws of indices to solve them. Alright? So the first one is pretty straightforward. We have 3 raised to the power n minus 1 times 3 raised to the power 1 minus n. Alright? Now if you look at this closely, you notice that the bases are the same. Alright? And they are multiplying each other. What law comes to mind? That's the first law of indices. So the first law of indices tells us when you have the same bases multiplying each other, you simply add their powers. So that's what we are going to do here. We are going to just write 3 raised to the power, we are going to add their powers. That is n minus 1 plus 1 minus n. So when you collect like terms, you are going to have 3 raised to the power n minus 1 plus 1. n minus n is 0, minus 1 plus 1 is 0. That means you're having 3 raised to the power 0 in the end. Alright? And according to law 3 of indices, this is equal to 1. Pretty straightforward, right? Now let's move further to the second one. Now this second one may look a bit complex, a bit difficult. But is it? We have the square root of 72a cubed b raised to the power minus 2 divided by 2a raised to the power 5b raised to the power minus 6. Alright? What is involved here? If you notice, we have some common bases dividing each other, right? We have A dividing A, we have B dividing B. It means we can make use of law 2 of indices. That says when two bases are dividing each other, you simply subtract their powers. That's what we are going to do here. So there's nothing complex actually. The question looks complex, but the solution is actually very easy. So first of all, you divide these two numbers naturally, as we've explained. 72 divided by 2 gives you 36. Now we are going to be subtracting the powers. The one at the top is dividing the one at the bottom, which means it is the power up. We will subtract the power down from it. So this will be 36 a raised to the power. We write the one at the top first. 3. This divide sign turns to minus. The one at the bottom is 5. Alright? And then for b, we have b raised to the power minus 2 minus 6. Alright? So that is it. And it becomes much easier to look at. So this is equal to square root of 36 a raised to the power 3 minus 5 is the same thing as minus 2. And then for b, we have minus 2 minus 6, which is the same thing as minus 2 plus 6, which is the same thing as 4. So we have 36a2 b4. Alright? But is that the final answer? Of course not. We have a negative power. So we are going to apply law 5 that says when you have x raised to the power a negative power, you bring it under 1 and make that power positive. So we are going to bring this back under 1, alright, and make the power positive. We are going to have square root of 36 times 1 over a squared times our b4. Alright? So that is it. That's basically it. So now if you notice, all of them are actually multiples of 2, or they have perfect squares. So what is the square root of 36 at the end of the day? The square root of 36 is equal to 6 times, what is the square root of 1 over a squared? It's 1 over a. And what is the square root of b4? It's going to be b squared, because b squared times b squared is going to be b raised to the power 4. So the final answer is 6b squared all over a. And that is the final answer. Alright? So now let's look at this third example, but I'll have to create space for it by cleaning some of these. We have 125 squared raised to the power minus 1 over 3 all squared. What do? First step, try and always remember, take care of the negative power. How do you take care of negative power? You apply law 4. Alright? So what does that law tell us? When we have a negative power, bring everything under 1. Alright? So we are going to be having is equal to square root of, you bring everything under 1 over 125 squared raised to the power 1 over 3. Are we together? Alright? So we brought everything here under 1 because it's everything here that has this negative power. So we have to bring everything under 1 and the power becomes positive. Alright? So what do we do next? Now, you can decide to go through a long method of taking your calculator to find out what 125 squared is, and then you cube it. But this is where I tell you that this is why you need to know how to represent some numbers in terms of powers that are divisible by other powers in the question. For example, I can see that there's a power of 3 here, power of 2. I know I can represent 125 as 5 times 5 times 5, which is 5 cubed. And I'm going to, instead of 125, I'm going to replace it in 5 cubed here, because it's going to make my work easier and faster. Alright, so this gives me square root of 1 over, I'm going to turn this 125 to 5 cubed. I will not forget the square, all squared. And I will also not forget my 1 over 3. Now I can multiply all these powers, right? When you have the powers outside bracket multiply each other, I can multiply 3 times 2 times 1 over 3. So 3 times 2 times 1 over 3, 3 will cancel 3, and you're left with just 2. So out of all these powers, you see that why I prefer to make it 5 cubed. It has made my work easier. This 3 has cancelled this 1 over 3, and I'm left with just the 2. So that means I'm having square root of 1 over 5 squared. Alright? Which is what? Root 1 over 25. So what is square root of 1 over 25? Is equal to 1 over 5. Yes, because 1 over 5 times 1 over 5 is equal to 25. In this place, your answer has simply come out. Alright? There is another way to also get your answer from here. As I've said in law 7, sometimes we can turn this back from law 7. We know that since we have the square root sign, it means we have 1 over 25 raised to power 1 over 2. Alright? This is law 6. Since it's a square root sign, I know that I can represent it in this form. And I can also represent 25 as what? 5 squared. So this is something as 1 over 5 squared, right? Times 1 over 2. Are we together? So we are going to have this multiply. The power outside is going to multiply the one at the top and also the one at the bottom. Alright? I'll create some space for it here. I'm going to have 1 times 1 over 2, 1 over 2, and over 5 raised to the power 2 times 1 over 2. 1 raised to the power anything is always 1 over these 2, we cancel these 2, and I have 1 over 5 as my final answer. Whatever method you understand, whatever method works best for you, that is it. Alright? Well, that is how indices works. If you need more examples, ask some questions that you have in the comment section and let me know the areas you do not understand. Thank you very much for watching this video on indices to the end, and I will see you in my next class.